Hello, Geometry. This is Lesson 3, Segment Relationships, Part 2, and our big ideas here are the Pythagorean theorem and the distance formula. And after we talk about what these two things are, you'll be able to use them to find unknown lengths, okay? So, without further ado, let's start with the Pythagorean theorem. And obviously it's a theorem, but really it's just a formula, okay? So, what we say it is a squared plus b squared equals c squared. So that's our formula. But what does that really mean? So now let's look at our picture here, okay? We have to have a right triangle in order for this to work. That is the absolute must. You can't do it with any other triangle. Now with this a squared plus b squared business, those are just your side lengths. So like here's my a, and then you square it. And then here's the b length, and then you square it. And then your C is always across from your right angle, and we call that the hypotenuse, and I'm just going to abbreviate it with height. And then that equals C squared. So again, this is all we're doing, okay? Taking our leg lengths, squaring them, adding them together, and they equal our hypotenuse squared. So let's try one out. So it says find the length of the unknown side. Okay, so we're looking for our hypotenuse. Do you guys see that? Because this is the side across from that right angle. So there's our hypotenuse. And now we just plug in straight to our formula. So I'm going to have 12 squared plus 9 squared equals x squared. So that's what we're looking for. Okay, now just crunch some numbers. 12 squared is 144. 9 squared is 81. Equals x squared, so we're still looking for that. We don't know what it is. Now 144 plus 81 is 225. Now to get rid of this squared term, we take the square root. So we gotta do something squared. Take the square root. Unfortunately for us, 225 is a perfect square, so we get a whole number, which is nice. So we get 15 equals x. There we go. Try another one. It's set up a little bit differently. This time, we know our hypotenuse, right? We know that's 10. So we're looking for one of our leg lengths. So again, we're going to set it up the same way. 4 squared. This time I don't know what that leg is, so I'm just going to say x squared equals 10 squared, our hypotenuse. Now again, crunch some numbers. 16 plus x squared. 10 squared is just 100. And remember, we want to get x squared by itself, so I need to subtract 16 from both sides. Those go away. And I'm left with x squared equals 84. Now our last step again is to take the square root. However, this time we don't get a perfect square. We don't have a perfect square on our hands. We're going to get a decimal. So since we're going to approximate our answer, we do a little squiggly equal sign, and that means approximately. And we're going to round to the nearest tenth, so 1 decimal place. So the square root of 84 is approximately 9.2. Find the length of AB. Well, this is just a segment, right? We don't even have a triangle here. What am I going to do? Well, let's just make a triangle. It's that simple. So let's just make our leg. There's one of our legs. Here's my other leg. There's my right angle. And now we know that this length of AB, we can just call that x, because that's what we're looking for. But how am I going to find out how far it is from here to here? Well, simply just count, okay? And we find that to be 5. Just count the spaces, right? And then from here to here, again, by just counting, we see that that is 6. And now we have a problem like before. So I'm going to have 5 squared plus 6 squared equals x squared. So that's my hypotenuse, and that's the length we're looking for. Again, crunch some numbers. 5 squared is 25. 6 squared is 36 equals x squared. Send this down. There we go. 25 plus 36 is 61. Again, our last step is to take the square root. You notice that we don't have a perfect square in our hand, so we're going to get a decimal. So we're going to get x is approximately 7.8. But now since they were asking for a specific length, we said to find the length of AB. I'm also going to write it as AB, and since I'm talking about its length, we put there's no segment bar on top, so not like that, just AB equals 7.8. So as you can see, each problem gets a little bit more interesting, right? Before we had triangles, this time we just had a segment on a plane. Now here, we just have two coordinates. We don't even know. We don't even know what it's talking about. So, can I make my own triangle? Can I put these on a coordinate plane? Sure we can. So let's just have, let's say, AB right here. And that's negative 15, 4. There's my segment. Call that B. And we know that that's negative 6, 11. Okay, so now we have a problem like we did right here. Okay, now how did we go from just a segment to a triangle? We drew it in. So let's draw one in. There's my triangle. And now the question is, how am I going to know how far it is from here to here? Well, on here, we just counted, right? All we did was count from there to there. So that all we were doing was finding the change in our x-coordinates. So what's the difference in our x-coordinates? So the difference, remember, is just subtraction. We did this the other lesson. So I'm going to have negative 15 minus negative 6. Remember, that's your leg length, so we square it. And then we're going to add that to the difference of our y-coordinate, which will give us this leg length. So I'm going to have 4 minus 11 squared. Okay, now we're just going to crunch some numbers here. Subtraction means add the opposite. So negative 15 plus 6 is negative 9 squared plus 4 minus 11 will give me negative 7 squared. And remember, this all equals c squared. Okay, and the reason why I left these in parentheses here, because when you punch this into your calculator, if you just hit negative 9 squared, it's going to give you negative 81. But we know that a negative times a negative is a positive, so if you leave that negative there, you have to make sure you put it in parentheses and put the squared on the outside to get the positive value. So we get 81 plus 49 equals c squared. Now adding those two numbers together, we get 130 equals c squared. And remember, our last step, as always, is to take the square root. So we find c to be approximately, because that's not a perfect square, 11.4. And again, they were asking us to find the length of AB, so we're going to write it as AB, no bar on top because it's the length we're talking about, is approximately 11.4. Now actually what we just did there, you guys, is we just did the distance formula. So this formula right here is exactly what we just did. Now the distance formula, we use it when we don't necessarily have a graph that has coordinates that are nicely to plot. We're not always going to have numbers that are below 10. What if it was 407 or something, right? We don't want to plot that. So we can use this formula and just plug in to find our distances. So look, as you can see, here's my point A. There's my point B. We found the difference of the x-coordinate, so that's where we get this piece right here. And then to find the other leg, we found the difference in the y-coordinate, which gives us our other leg. So again, the distance formula is just your x-coordinates subtracted by each other squared plus your y-coordinates subtracted by each other squared. So let's try a problem using the distance formula. So it says, what is the distance between 6, negative 2, and negative 5, 3? Round to the nearest 10. So we're going to use now the distance formula. And at first, I'm just going to label these for you guys. I'm going to have this be my x1, y1. So those are my x and y coordinates. Then x2, y2. Now I'm just gonna plug in to this guy. So D stands for distance, is the square root. Now it says x2 minus x1, so here's my x2, there's my x1, so negative 5 minus 6 squared, so I'm just copy it down what the formula says, plus, now it says y2 minus y1 is right there, so y2 is 3 minus negative 2 squared. Now, we just crunch some numbers here, it's just strictly arithmetic. So negative 5 plus negative 6, we get negative 11 squared plus, subtraction means add the opposite, so 3 plus 2 is 5 squared. So negative 11 squared is 121, 5 squared is 25. Adding those together, we get, let's see here, 146. Press turn the page here on the notes. And then we find that the square root of 146 is approximately 12.1. All right, thanks guys for watching. If you have any questions, let me know. If not, we can talk about these in class tomorrow.